Welcome to Spring LIB.
7.69. So we have an elevator whose cable breaks when it's 22.5 meters above the top of a gigantic spring that's in the elevator shaft for some reason. So first we want to find the work that gravity does between the point where the cable breaks and when the elevator comes into contact with the spring. And then we want to find the speed of the elevator just before it hits the spring. And then we want to find the amount that the spring will compress. And here, work is being done both by the spring and by gravity, so we'll have to be a little bit careful. So to begin with, the only force acting on the elevator while it's falling until it hits the spring is gravity. So the total work that does is going to be the weight of the car times the distance it falls. There's a 22.5 meters here. And then the cosine of the angle between the force and the displacement is 1 because the angle is 0. So this is 2.04 times 10 to the 5th joules. Because gravity is the only force doing any work on the car until it hits the spring, the work done by gravity is equal to the change in kinetic energy and since it's starting from rest, it's 1/2 mv squared minus 0. So the speed is the square root of 2 times the work that gravity did divided by the mass. And so it's going 21.0 meters per second when it hits the spring. So the elevator is starting from rest, and then when it reaches the bottom of its travel on the spring, it's at rest again. And so the net amount of work that's done on it between those 2 points has to be 0, because the change in its kinetic energy is 0. So gravity is doing positive work the whole way as it falls 22.5 meters, and then d or x or whatever that compresses it, let's call it x. We already used d. We usually use x for spring compression anyway. And then the spring's going to do negative work on the elevator to remove kinetic energy from it and store it in the spring. So the work that the spring does is negative 1/2 kx squared. And the work that, let's just write out the entire work. So the net work is equal to the work done by gravity plus the work done by the spring. Gravity does a work of mg times d plus x. And then, as we just said, the spring does a work of negative 1/2 kx squared. This has to be 0. So we have a quadratic equation here. 1/2 kx squared minus mgx minus mgd equals 0. So x is going to be mg plus or minus the square root of m squared g squared minus 4 times 1/2 k times negative mgd over 2 times 1/2 k is just k. So we want to take the positive root here because we assumed in our and how we set this up that x is positive. And so then, just plugging in the values for all of these things, and you might want to simplify some of this first before you go plugging numbers in. But either way, you get 2.37 meters is the distance that the spring compresses before the elevator stops.